Hi, welcome all to the online classes. I'm Mukesh Bhardwaj. Today going to represent the topic analog communication in the subject communication system, BTech Electronics and Communication, fifth semester. As we know that analog communication or word communication is basically is a process of establishing connection or link between 2 points of information exchange or communication is simply the process of conveying message at a distance or communication is the basic process of exchanging information. The electronic equipments which are used for communication purpose are called communication equipments. Direct or different communication equipments were when assembled together form a communication system. Typical example of communication systems are telephony and line telegraphy, radio telephony and line telegraphy, radio broadcasting, point-to-point communication, and mobile communication, computer communication, radar communication, television broadcasting, radio telemetry, radio aids to navigation, radio aids to aircraft landing, etc. The earliest communication system, namely line telegraphy, originated in 1814. In addition to this, line telegraphy or telephony came a few decades later, whereas radio communication could become possible in bringing of 20th century on innovation of triode wall. Radio communication, radio communication basically uh, was further greatly improved during World War II. It became more widely used through the invention of transistor, integrated circuits, and other semiconductor devices in subsequent years. Also, in recent years, communication has become more widespread with the use of satellites and fiber optics. Today, there has been an increasing emphasis on the use of computers in communication. The communication process were the elements of the communication system. In the most fundamental sense, communication involves the transmission of information from one point to another through a succession of process as listed, the generation of a thought pattern or image in the mind of an originator, the description of that image with a certain measure of precision by a set of oral or visual symbols, the encoding of these symbols in the form that is suitable for transmission over a physical medium of interest, the transmission of the encoded symbols to the desired destination, the decoding and the reproduction of the original symbols, the recreation of the original thought, pattern, or image with a definable degradation in quality in the mind of a recipient. Has The purpose of communication system is to transmit an information bearing signal from a source located at one point to user or destination located another point some distance away. So under the communication, analog communication, so this is the what is the communication system, what are the major types of it. Analog or the communication system is major type of analog or digital, satellite, fiber, wireless. What are the theorems which are we are going to study, what are the major components, how is the information transmitted, what are the current industrial standards, what are the state of art research, can I find a job by studying this course, can I find research topics. So this is the course description and the brief information or the definition related to the communication. Required textbooks, that is Modern Digital and Analog Communication System, Lathi, BP Lathi, and DING. Required software, MATLAB, or type Helpin in MATLAB environment. Recommended readings, Digital Communication, J. Process, Digital Communication. Random Process, G.R. Grimet and D.R. Streitzager, Probability and Random Process. Estimation and Detection, H.B. Poor, and Introduction to Signal Detection and Estimation. Information Theory, T.M. Cover and J.A. Thoms, Elements of Information Theory. Error Correct Coding, P. Sweeney, Error Control Coding. So these are the some recommended books and the recommended readings and some references. Communication system, engineering, social system. and the genetic system. So, history and fact of communication by the diagrammatic, in any sense of way, we are using the communication from a very earlier time. So, this is the communication system components. The transmitter side and the receiver, how the communication systems, what are the basic building blocks are used of block diagram. Through the mode of block diagram, we are going to learn about the how the information is transmitted from one end to another end. From the source input, that is the transmitter side, a source coder, then to the channel coder, then it is then modulation, then digital to analog conversion, then distortion and noise introduced over there, an analog to digital converter, then demodulation, and then channel decoder, then source decoder, and the reconstructed signal output at the receiver end. So these are the some basic system communication system components. Communication process, message signal, then symbols, then encoding, then transmission, then decoding, then recreation, broadcast, point to point. So this is basic theme of communication process. Telecommunications, telegraph, fixed line telephone, cable, wire networks, internet, fiber communication, communication bus inside computers to communicate between CPU and memory units. In wireless communications, satellite is a wireless communication, trans and television, cordless phones, cellular phone, wireless LAN and Wi-Fi, wireless MAN, WiMAX, Bluetooth, ultra wideband, wireless laser, microwave, GPS, ad hoc, and sensor networks. Now, analog or digital communication, common misunderstanding. Any transmitted signals are analog. No digital signal can be transmitted. Analog message, continuous in amplitude and over time. These are AM, FM, and PM. The AM, FM for voice sound, traditional TV for analog video, first generation cellular phone, analog mode, record player, digital messages, 0 or 1 or discrete values. In the VCD and DVD, 2G and 3G cellular phones, data on your disk, your grade. Digital age, why digital communication will prevail. So, analog to digital conversion or converter, or digital to analog converter or conversion are the process that allow digital computers to interact with these everyday signals. So we required a converter, analog signal to be converted into digital, and then wherever the end user is using, then digital signal is converted to the analog signal where it is going to be used. The source coders and digital camera encoder, TV computer decoder, camcorder, phone, read the book. Now theorems, how much information is measured by entropy, more randomness, high entropy, and more information. Power, channel, and noise. The three terminology used in communication, that is power, channel, noise. The transmit power constrained by device, battery, health issue, etc. Channel response to different frequency in different time. Satellite, almost flat over frequency change, slightly over time. Cable or line, response very different over frequency, change slightly over time. Fiber is perfect. Wireless, worst, multipath, reflection causes fluctuation in the frequency response. Doppler shift causes fluctuation over time. Noise and interference. AWG and Gaussian noise, additive white Gaussian noise. Additive white Gaussian noise, AWG stand for this. Interference, power lines, microwave, other users, CDMA phones. Now, Shannon capacity, the Shannon theory, it established that a given a noise channel with information capacity C and information transmitted at rate R, then if R is then the capacity C, there exists a coding technique which allows the probability of error at the receiver to be made arbitrarily small. This means that theoretically it is possible to transmit information without error up to limit C. So, the information source, we knew that a communication system serves to communicate a message or information. This message or information originates in the information source. In journal, there can be various messages in the form of words, group of words, codes, symbols, and sound signal, etc. However, out of these messages, only the desired messages is selected and conveyed or communicated. In short, we can say that the function of information source is to produce required message which has to be transmitted. Input transducers is a device which converts, that is, we are using coding or encoding. So basically, they are also called in general as transducers, which convert one form of energy into another form. The message from the information source may or may not be electrical in nature. In case when the message produced by the information source is not electrical in nature, an output transducer is used to convert it into a time varying electrical signal. Transmitter, the function of a transmitter is to process the electrical signal from different aspects. For example, in radio broadcasting, the electrical signal obtained from sound signal is processed to restrict its range of audio frequency up to 5 kilowatts in amplitude modulation radio broadcast and is often amplified. In wire telephony, no real processing is needed. However, in long distance radio communication broadcast, single amplification is necessary before modulation. Modulation is the main function of the transmitter. In modulation, the message signal is superimposed upon the high frequency carrier signal. In short, we can say that inside the transmitter, signal processing such as uh, frequency carrier signal or such as restriction of range of audio frequencies, amplification and modulations are achieved. All these processings of message signal are done just to ease the transmission of signal through the channel. Now the channel and the noise, with the reference to the block diagrams which we had seen for the communication system, the term channel means the medium through which the message travels from the transmitter to the receiver. In other words, we can say the function of the channel is to provide a physical connection between the transmitter and the receiver. There are two types of channels, namely point to point channels and broadcast channels. For example, point to point channels are wire lines, microwaves, links, and optical fibers. Wire lines operate by guided electromagnetic waves and they are used for local telephone transmission. In case of microwave links, the transmitted signal is radiated as electromagnetic wave in free space. Microwave links are used in long distance telephone transmission. An optical fiber is a low loss, well controlled guided optical medium. Optical fibers are used in optical communication. Although these three channels operate differently, they all provide a physical media or medium for the transmission of the signal from one point to another point. Therefore, for these channels, the term point to point is used. On other hand, the broadcast channels provide a capability where several receiving stations can be reached simultaneously from a single transmitter. An example of broadcast channel is satellite in geostationary orbit, which covers about one third of the Earth's surface. During the process of transmission and reception, the signal gets distorted due to noise introduced in the system. Noise is unwanted signal which tend to interfere with the required signal. Noise signal is always random in character. Noise may interfere with signal at point in a communication system. However, noise has its greatest effect on the signal in channel. Receiver, the main function of the receiver is to produce the message signal in electrical form from the distorted receiver's received signal. This reproduction of original signal is accomplished by a process known as the demodulation or detection. Demodulation is the reverse process of modulation carried out in the uh, demodulation is the reverse process of modulation carried out in the receiver. Destination is the final stage which is used to convert electrical message signal into its original form. So, what are the sources of information? As we had discussed, as a matter of fact, the telecommunication environment is dominated by the following four important sources of information: speech, television, and facsimiles, and the personal computers. A source of information may be characterized in terms of signal, which carries the information further. A signal is defined as single valued function of time that plays the role of dependent variable. At every time or every instant of time, the function has unique value. So, the converse is also important. If R is greater than C, the probability of error at the receiver increases. Without bound, without bound, as the rate is increased. So, no useful information can be transmitted beyond the channel capacity. The theorem does not address the rare situation in which rate and capacity are equal. So, Shannon channel capacity C equals to B log base to 1 plus standing noise ratio or sound to noise ratio bits per second. Now, modulation, the process of varying a carrier signal in order to use the signal to convey information. Carrier signal can transmit far away, but information cannot. So, modem, amplitude, phase, and frequency. So, modulation is a process by which a massive signal is superimposed on a carrier signal for transmission to a long distance. So, according to the uh, carrier signal, we are going to modulate the original signal, and the modem that is based on the amplitude modulation, phase modulation, or frequency modulation. In analog, amplitude AM, amplitude modulation, amplitude FM frequency, vestigial sideband modulation. Digital, mapping digital information to different constellations, frequency shift keying, QPSK, FSK, PSK. Channel coding, deliberately purpose and add redundancy to the transmitted information so that if the error occurs, the receiver can either detect or correct it. Source channel separation theorem: if the delay is not an issue, the source coder and channel coder can be designed separately. That is, the source coder tries to pack the information as hard as possible, and the channel coder tries to protect the packet information. Popular coder, linear block code, cyclic codes, convolution codes, LDPC codes, turbo code, zero point 0.1 decibel to channel capacity. Mean square quality of link, that is services or quality of services. Mean square error, the formulas to be used: signal to noise ratio, SNR, bit rate, bit error rate, frame error rate, packet drop rate, peak signal to noise ratio, SINR, SNIR, signal to noise pulse interference ratio, or human factor. So, multiplexing is the simultaneous transmission of many signals through a single channel. So, multiplexing, there are various type of multiplexing: time division multiplexing, frequency division multiplexing, code division multiplexing, space division multiplexing. So, multiplexing is the simultaneous transmission of many signals through a single channel. Now, we are just seeing in the diagram that is a red color line wirelessly is a channel, open air channel, and if so many signals are need to be transmitted from the transmitter side to the receiver sides, then know that there is a range of transmitting the signal in a particular frequency. So only one user cannot have the right to transmit the signal from one end to another. Other also want to transmit in the same frequency range. So we just develop a technique of transmitting a signal from one end to another, and by frequency division multiplexing, that time division multiplexing, or we can use code division multiplexing or CDMA, and the space division multiplexing. Communication networks, connection of two or more distinct, possibly dissimilar networks, require some kind of network device to facilitate the connection. And basically, routers, or we can say the switches are connected first, then to the routers, and there is a specific algorithm for that to route the data packets or the signal packets, and it's reached to the uh, in a very shortest time, or in the shortest path. They choose according to the traffic density and channel capacity. Broadband communications, SONET as their designations and bandwidth. SONET optical carrier level OC1, OC3, OC12, OC24, and these are the some SONET optical carrier level designations. SONET frame format, these are the format related to the carrier level, and SDG level and frame format related to the carrier level. Payload bandwidth, kilobytes per second, line rate, kilobytes per second. So these are the various designations and bandwidths for broadband communication. OSI model, that is Open System Interconnects, ISO OSI model. Basically, it is the Indian Standard Organization, International Standard Organization Open System Interconnection, and that is in the networking. OSI model is very similar to the, because as we knew that we are transmit any signal, or we are just doing anything electronic message transmission through the electronic mode, then there is some sort of protocols needed to be applied for transmitting the signals from one end to another. So as an analogy of sending a mail, if I'm talking about a, suppose if you want to write a letter and you need to send your letter to your friend, in the earlier time what we need to do, that first we write a letter in a proper format with proper syntax and semantics, and then we just cover that letter, put that letter in the envelope, then paste the envelope and put a stamp over it, and, then we went to the uh, red box and drop a letter over there, and the person or employee from the postal department comes and collect the letters from that red drop box, and just take all the letters to the GPO, General Post Office, or the Central Post Office system, or nearby the local post office. There, the assorting takes place according to the reason wise. There, we just get assorted and the letters according to the reason, or according to the pin code wise. Then the next protocol is just we are going to deliver the letters through various modes of or means, by road, by railway, by uh, water, by air. So it depends upon the reason also where we are going to send that letter. After that, these letters reach to the uh, general post office of that particular region, and again it is assorting according to the area wise, the local area wise, and then assorting of that letters done, then the individual area postmans take the letters and went to go for the dispatch to the end user. So there is a protocols how you are going to be just transmit your message from one end to another end. Similarly, in the electronically system or the electronically, if you want to transmit the message or signal, for example, in the case of electronic mail or email, uh, first the OSI model set of protocols, and it is open system interconnection, international standard organization, in which the application layer, then the presentation layer, then the session layer, then transport layer, then network layer, then data link layer, then the physical layer. So at the level of that is, if I'm talking about the first four, and this is 7 layer protocol. So the first four layers are known as host layers, and the last 3 layers are known as the media layers. So at the application layer, data is to be processed and synthesized. Again, at the presentation, the data representation and encryption takes place in the application network process to application. And the third layer, that is session, inter-host communication of the data. And the fourth layer, that is transport, end-to-end connections and reliability is set. And then segments of the data takes place. And then network layer, the protocol of the network layer comes into the existence, that is part determination and logical addressing IP. Then the data just convert into segments, convert into packets, and after that these packets move in the form of frames through the data link layer, that is physical addressing MAC layer or LLC. And after that, that frames are converted into bits and transmitted through the physical layer, that is media, signal, and binary transmission. So it is a very important open system interconnect. OSI model is a very important model in the reference model for uh, electronic communication. And TCP/IP, Transmission Control Protocol, Internet Protocol Architecture, is the de facto global data communication standard. It has It has lean 3 layer protocol stack that can be mapped to 5 of the 7 in the OSI model. TCP/IP can be used with any type of network, even different types of networks within a single session. History of telecommunication, audio signals, prehistoric communication, drums, horns. This is the history of telecommunication, in which year what invent or what he had invented. Advanced electrical electronic signals. So it is important to the history point of view. Now, baseband and carrier communication. Baseband describes signals and systems whose range of frequency is measured from 0 to maximum bandwidth or highest signal frequency. Voice, telephone 0 to 3.5 kilohertz, CD 0 to 22.05 kilohertz, video analog TV 4.5 megahertz, TV channel is 6.0.6 megahertz, digital depending on the size, movement frames per second. Example, wires, coaxial cables, optical fiber, PCM phones. Carrier communication, a waveform, usually sinusoidal, that is modulated to represent the information to be transmitted. This carrier wave is usually of much higher frequency than the modulating baseband signal. Modulation is the process of varying a carrier signal in order to use that signal to convey information. Example on the board, or in the next slide we are just modulation, a process that causes a shift in the range of frequency of signal. What is gain advantages? Antenna size, half of the antenna size, thousands of miles for baseband, better uses of limited bandwidth, less side loops, great bandwidth for SNR, CDMA, robust to inter-symbol interference, that is multi-part delay, robust to errors and distortions. Types: analog, amplitude modulation, double sideband, single sideband, vestigial sideband, and frequency modulation and phase modulation, then delta modulation. And the digital modulations are of the type ASK, frequency shift king, PSK, phase shift king, quadrature amplitude modulation. And the pulse modulation is the pulse coded modulation, that is PCM, pulse digital modulation, PDM, fiber phones, advanced type of modulation, CDMA 3G, OFDM in W lane, and VMAN, that is orthogonal frequency division multiplexing. Double sideband modulation, MT cos omega CT 0.5 m omega minus omega c plus m omega plus omega c. Lower upper sidebands, double sidebands suppress carrier, no carrier frequency. Uh, WC is greater than or equal to the bandwidth of the signal to avoid aliasing. The demodulation, the equations arises like this. Low pass filter to remove the higher frequency. Coherent and non-coherent detection. Receiver can recover the frequency and phase of the transmitter by phase lock loop PLL. Error of timing can cause the performance error floor. Non-coherent receiver has 3 dB worse performance than coherent. Cheaper for non-coherent receiver next. So these are the diagrammatic representation of the waveforms, single sideband, double sidebands or amplitude modulated waves. Multiplier modulators multiply MT by cos omega CT, hard for linearity for high energy expensive. Examples, sound systems. Nonlinear modulators, examples. Switching modulators, FFT transformed to series of frequency. Series bridge diode modulator, shunt bridge diode modulator, ring modulator. Frequency conversion, move the signals to other frequency, multiplying two sinusoidal results. Multiplying two sinusoids results into two frequency, which are sum and difference of the frequency of the sinusoids multiplied. Uh, Cos alpha t cos beta t is equals to 1 by 2 cos alpha minus beta t plus cos alpha minus beta t. To change the carrier frequency omega c of the modulated signal to an intermediate frequency omega, we use an oscillator to generate a sinusoid of frequency. Maxwell's that. So these are the some diagrammatic representation of the waves. Why double sideband suppress carrier not working? Do not know the carrier frequency in receiver. The last impulse function indicate the carrier is not suppressed. In this case, for some shown the modulated signal spectrum is shown. Phi mt equals to a plus mt cos omega ct, and this is the equation of the amplitude modulation wave. Which this type of amplitude modulation, the demodulation can be performed uh, with or without local oscillators synchronized with the transmitter. Next, amplitude modulation example. MT has a minimum value of about 0.4. Adding a DC offset of A equals to 1 results in A plus MT being always positive. Therefore, the positive envelopes of it is just A plus MT. An envelope detector can be used to retrieve this. The choice of DC offset should be such that the choice of DC offset should be such that That A plus empty should be always be positive. Otherwise, the envelope detector cannot be used, but coherent is still okay. Modulation, therefore, modulation is the fundamental requirement of communication system. Modulation may be defined as process by which some characteristic of a signal known as carrier is varied according to the instantaneous value of another signal, known as modulating signal. The signals containing the intelligence or information to be transmitted are modulating signals. These modulating signals containing the information are also called baseband signals. Also, the carrier frequency is greater than the modulating frequency, and the signal which results from the process of modulation is known as modulated signal. Modulation may be classified as continuous wave modulation and pulse modulation. If the carrier waveform is continuous in nature, then the modulation process is also called the continuous wave modulation. The example of this type of modulations are amplitude modulations and angle modulation. On the other hand, if the carrier waveform is a pulse type waveform, then the modulation process is also is called as pulse modulation. The examples which we had already discussed for this type of modulations are pulse amplitude modulation, pulse width modulation, pulse code modulations, etc. So amplitude modulation, angle modulations are two families of continuous wave modulation system. In amplitude modulation, the amplitude of a sinusoidal carrier wave is varied in accordance with the baseband signal. On the other hand, in angle modulation, the angle of the sinusoidal carrier wave is varied in accordance with the baseband signal. Amplitude modulation is discussed in this chapter or in the slides, and we had already discussed that about the multiplexing. I had already told you that simultaneous transmission of many signals through a single channel. So multiplexing is a technique in which several massive signals are combined into a composite signal for transmission over a common channel. In order to transmit a number of these signals over the same channels, signals must be kept apart so they do not interfere with each other, and hence they can separate it easily at the receiver end. So multiplexing is basically of two types under the frequency division and time division. And the third most, which we had already discussed, that the code division CDMA techniques also for the multiplexing. So we had discussed about the amplitude modulation. Amplitude modulation may be defined as a system in which the maximum amplitude of the carrier wave is made proportional to instantaneous value or amplitude of the modulating or baseband signal. Here the baseband signal means the massive signal. So for that, we know that the sinusoidal wave, carrier wave, the nature of the carrier wave is sinusoidal. So we know the equation of sinusoidal equations can be given as a CT or MT or is the CT. Here the carrier is talking the CT is equals to A cos omega CT. Here A is the maximum amplitude of the carrier wave and omega C is the carrier frequency. Now, let denote the modulating baseband signal with xt. Then, according to amplitude modulation, the maximum amplitude of A of the carrier will have to be made proportional to instantaneous amplitude modulated signal xt. So, the standard equation for the amplitude modulation may be expressed as xt cos omega ct plus A cos omega ct. So, st is equals to A plus xt cos omega ct. So according to the equation discussed, we are just seeing that modulating signal, baseband signal, carrier signal, or modulating signal. Next. So modulation index M, up to which extent we can modulate the signal is known as modulation index, and its value lies between 0 and 1. So modulation index is defined as let MP be the absolute negative peak of MT. A single tone modulation, let MT equal to 2 sine omega 2 sine 20t. So A is greater than or equal to MP. A is the carrier amplitude. Modulation index is given by mu equals to MP by A. Then we see that for A greater than or equal to MP, modulation index lies between 0 to 1. when mu is greater than 1 or modulation index is greater than 1, the signal is over modulated and envelope detection cannot be used. However, we can still use synchronized demodulation. Sideband and carrier powers. Again, the important terminology. The first term is a carrier and the second term is the sideband, which contains the signal itself. The total amplitude modulated signal power is sum of the carrier power and the sideband power. The carrier power is given by PC equals to A square by 2 and sideband power is equal to P square 1 by 2 PM, where PM is the power of MT, that is massive signal. Sideband power is the useful power. Now the efficiency is the output upon input. So neta is given as useful power upon the total power, and this come out to be PM upon A square plus PM. For example, let MT massive signal B cos omega MT omega MT. So MP equals to B, mu equals to B by A, or B equals to mu A. So PM, that is B square by 2, and B can be written as mu square A square by 2, or now neta, or that is efficiency, can be useful power upon total power. So mu square upon 2 plus mu square into 100, that come out to be 33% for mu equals to 1. Now AM generator, this is the amplitude modulation generator diagram, how the AM signals are generated. Coherent detector for demodulating double sideband suppressed carrier modulated wave. Amplitude modulated non-coherent detector, rectifier detector, synchronous envelope detector, and these are the some presentation or diagram shown. Now quadrature amplitude modulation QAM. See the diagrammatic representation, how the signal is transmitted through the synchronized way, and how the block uh, diagram is showing that how it is actually converted and then transmitted. So amplitude modulated signal bandwidth, amplitude signal bandwidth twice the bandwidth of the modulating signal. A 5 kilohertz signal requires a 10 kilohertz bandwidth for amplitude modulation transmission. If the carrier frequency is 1000 kilohertz, the amplitude modulation signal spectrum is in the frequency range of 995 kilohertz to 1005 kilohertz. Quadrature amplitude modulation is a scheme that allows two signals to be transmitted over the same frequency range. The coherent in frequency and phase is expansive. TV for analog. Most modems work on the uh, quadrature amplitude modulation system. Now, sideband, single sideband proposed to reduce the bandwidth requirement of amplitude modulation by one half. This is achieved by transmitting only the upper sideband or the lower sideband of the double sideband amplitude massive signal. Because the upper sideband or the lower sideband contains the same information. So, to reduce the bandwidth requirement, we try to transmit only the upper sideband or the lower sideband. This is the diagrammatic representation, the how the signal is transmitted. A oscillator which generates the carrier frequency and the audio signal just through the balanced modulated band pass filter, then gives single sideband, and the single sideband signals are having uh, lower sideband and the upper sidebands, and they are need to transmit. Baseband, DSB, double sideband, and double sided and single sideband suppress carriers. Now SSB generator, single sideband generator, selective filtering using the filters with sharp cutoff characteristics. Uh, Sharp cutoff filters are difficult to design. The audio signal spectrum has no DC component. Therefore, the spectrum of modulated audio signals has null around the carrier frequency. This means a less than perfect filter can do a reasonably good job of filtering the DSB to produce the single sideband signal. Baseband signal must be band pass. Filter design challenges. Uh, Next, SSB generator block diagram, phase shift method using Hilbert transformer, non-causal filter approximation. SSB demodulation, this is the demodulation site. Single sideband versus amplitude modulation. Since the carrier is not transmit, therefore is reduction by 67% of the transmitted power. In amplitude mode, 100% modulation, 2 by 3 of the power is comprised of the carrier, with the remaining 1 by 3 power in the both sideband. Because in single sideband only one sideband is transmitted, there is a further reduction by 50% transmitted power. Finally, because one sideband is received, the receiver needed bandwidth is reduced by one half, thus effective reducing the required power by the transmitter another 50%. Vestigial sideband is VSB is compromised between DSB and SSB. To produce SSB signal from DSB signal, ideal filter should be used to split the spectrum in the middle so that the bandwidth of the bandpass signal is reduced by one half. In vestigial sideband system, one sideband and the vestige of the other sideband are transmitted together. The resulting signal has a bandwidth, the bandwidth of the modulating baseband signal, but less than the double sideband single bandwidth. Filtering scheme for the generation of VSB modulated wave. This is the block diagram representation for the filtering scheme. This is the mathematic equation and the block diagram for the VSB transmitter, transceiver. Other facts about the VSB: comparison, common types and amplitude signal. These are the tabular chart for the comparison of amplitude modulation, double sideband, quadrature amplitude, single sideband, vestigial sideband. Types of wave, as we know that waves are of depending upon of various range. In the ionosphere, long wave, space wave, TV phone, sky wave, short wave, ground wave, and how the communication takes place. These are the some radio frequency bands which we already know that extremely low, infra low, very low, low, medium, high, very high, super high, extremely high, tremendously high. These are the characters where they are going to be used: ground wave, ground sky wave, space waves. Satellite communication. So we will take this satellite communication in the next lecture. Satellite orbits, geostationary orbit. Geo, MEO, and LEO are the three stationary orbits, and depending upon the kilometer range. Geostationary orbit is near about 35,786 kilometer, and medium Earth orbit, that is situated at the 27,878 kilometers, and LEO is the lower Earth orbit, that is near about 347 miles away. International Space Station LEO, 249 miles. Now, thank you. That is all about the analog communication. Thank you.